guys, this is Mrs. Gastler, and in this video we're going to talk about how to draw a motion diagram. So I've got a notes page here for motion diagrams that we're going to go through and fill out together. First off, a motion diagram is a diagram, it's a picture that represents how an object moves. Okay. Here's some examples right here. This is a motion diagram of an object, and this is a motion diagram of an object. They're a little bit different, but we'll talk about that in a second. When the position is to the right of the origin, we call that x is positive. Okay, it's just like a number line. 0 is in the middle, positive is over here, and negative is over here. So negative and positive over here as well. When it's to the left, x is negative. So if you have information about where the object is, positive or negative, then you would put that on your diagram. You would put a 0 and put it there. Sometimes you don't have that information, and that's okay. So here we've got a stationary ball, and notice that there's one dot, and it's not moving, okay? So that object is just sitting there, there's only one dot. Over here we have a skateboard going down a sidewalk. It's moving at a constant speed, and so the dots are evenly spaced. Now this is kind of incomplete here because there's something else that we need to put on our motion diagram. I'll go ahead and complete it, and you can too, and that's arrows. These arrows represent what the object is doing, and so we would put those on there too, which we'll see in a little bit. Okay. The arrows tell you how fast it's going, so so we know that this object is going fast. There's no motion here. There is motion here, so we have some arrows to show that. So when we compare the motion diagram to a graph, you see here, this is our motion diagram here, and if we take it and we turn it and stick it here, we have our evenly spaced dots, which on our graph, when we spread them out over time, okay, so first second, second second, third second, fourth second, fifth second, we end up with some dots on our line, which we haven't talked a whole lot about graphs yet, but we did find the slope, and so that's where that slope is going to come in handy. Okay. On the next page, here's where we're talking about the arrows. When our arrows always point in the direction of motion. Arrows point in, velocity arrows point in the direction of motion. My paper is kind of bubbling up, so I'm trying to keep it down while I write here. That way it's not too sloppy. Okay. So if the direction of motion is to the right, then the velocity, the speed, is in the positive direction. So if you read a description of motion and it says that your object is going in the positive direction, then your arrow needs to point toward the positive. Negatives on the other side of 0, positives over here. Okay. If your arrow is pointing in the other direction, that means that V is negative. Your speed is in the negative direction. Your object is moving in the negative direction. Okay. So we're going to take a look at some of these, and we're going to describe what's going on. So here's our skateboarder again. The distance between the points is, okay, so look at the distance between the points. Every point is evenly spaced, so the distance between the points is the same. And the length of the arrows, you can hopefully see that those are all the same. You can write constant there if you'd prefer, indicating that the object moves with a constant speed. Okay, that's how we know, because we're looking at that sameness over and over again. The arrows are pointing in the positive direction. This is missing the ing. And I'm going to write a plus sign for positive because I'm lazy. Positive has a lot of letters. And the positive motion can be chosen to the right or left. So we've got 0 here. We're going to do positive and negative. I really could just turn this around, and now notice how positive is over here and negative is over there. But for the most part, we keep it this way. The positive direction is chosen to be to the right. All right, so that's what they did here. They turned it around. Okay, we'll do it this way. There you go. Now we have positive over here and negative over here. We're just looking at it upside down. Okay? So the distance between these points looks like it's the same to me again. And the length of the arrows looks like it's the same again, which tells me that this object is also moving with a constant speed. But my arrows are pointing now. They're pointing in, well, these guys are pointing to the left, but it's in the positive direction still. just because that's where the positive is and 0 is here. So when you have your arrow pointing this way, see how they compare there. And so this is, the left is positive this time. I will be honest, this does not happen very often. It's kind of advanced there. You won't see that on tests and quizzes, I'm pretty sure. Okay. All right, so let's take a look. Here we've got the tortoise and the hare, or a tortoise and a rabbit. They're both running with a constant speed, but the rabbit is running 4 times faster than the tortoise. Okay, so here we've got our motion diagram. You can see that it's 4 times faster because there's 4 arrows for the tortoise and there's only 1 arrow for the rabbit. Okay. The dots for the position of the rabbit and tortoise are drawn. The dots, they're evenly spaced because they're moving at a constant speed. But the dots for the tortoise are closer than those of the rabbit because the rabbit is faster, or the tortoise is slower. Okay. Hang on. Let's call this the tortoise. Tortoise is slower. That way we have it together. Closer is slower. The arrows for the rabbit are longer, okay, than those of the tortoise because the rabbit is faster. Longer arrows mean faster. Longer means faster, shorter means slower. Closer together, dots means they're slower. Farther apart, dots means they're faster. The dots of the rabbit and the tortoise may line up, but that does not mean that they are there at the same time. Okay, so our arrows are spaced out so that they're showing a certain amount of time. So in the first second, okay, in the first second, the tortoise is here. And in the second second, the rabbit is here. They line up right here, but it takes the tortoise 4 seconds to get there. By that time, the rabbit will be way over here off the page. Okay? So it doesn't mean they're together even though the dots line up. The dots are spaced out over time. Okay? All right, so last page here, we've got an example that I think we're gonna draw one here in a second. All right, so we've got a balloon. Notice how our balloon is rising, so we just turned our motion diagram up high. So negative is down and positive is up this time. So if I look, the distance between the points is the same again. And it looks like the lengths of my arrows are all the same. And so this balloon must be moving with a constant speed. Okay, the direction of the arrow indicates the upward, the direction, sorry, I didn't read the next part of the sentence. Direction of motion of the balloon, which is positive. Okay, so our balloon is going up in the positive direction. We just took our, so here's what the motion diagram looked on some of the other ones. We just turned it. Okay, sometimes it's useful to have our motion diagram go literally in the direction that the thing is going. Okay. All right, so summarize. A motion diagram is a series of snapshots. So here it is, there it is, picture, 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 taken at regular time intervals. Each time between the dots is the same amount of time. Okay, time intervals. It depicts the motion of an object over a chosen time period. I really don't know what's supposed to be here. Is blank, meaning blank. It should specify the direction. We're just going to leave that part blank. Okay. When an object stands still for a moment, we put a dot. If it's standing still over a period of time, we stack the dots like that. So there's going to be some examples of motion diagrams that you're going to be drawing, and that's likely going to be in a new video so that you can have some practice together. If you have any questions about how to draw some motion diagrams or how to analyze a motion diagram, make sure you ask your teacher. Thanks for watching.